Good evening to all the esteemed participants, faculty members, and distinguished chief guest, Dr. T. Palnichami sir. As we embark on the day 4 of our faculty development program of AICTE, Atal Online Faculty Development Program on Disaster Risk Management Analysis and Mitigations. We reflect on the past 3 days filled with valuable discussions on preparedness, response strategies, and mitigation techniques. Today, we move forward with renewed enthusiasm, dwelling deeper into the topic Structural Behavior of Fiber Reinforced Concrete for Risk Reduction by Dr. T. Palnichami, Department of Civil Engineering, NIT Surathkal. As Benjamin Franklin wisely said, by failing to prepare, you are preparing to fail. Let us continue our journey of learning, equipping ourselves with the knowledge to build more resilient communities. Wishing you all engaging and insightful session again. Thank you all. With this short welcome, now let me introduce today's chief guest, Dr. T. Palnisamy. Dr. T. Palnichami is currently working as Associate Professor in Department of Civil Engineering at National Institute of Technology, Karnataka, Surathkal, India. He has published 136 articles in journals and conference proceedings at national and international levels. He has delivered more than 194 keynote lectures in various levels sponsored by AICTE, CSIR, DRDO, and DST. He also secured funded projects from DST SERB, DBT, AICTE. At present, 2 funded projects is going on with a worth of 0.70 crores for the development of concrete battery. And 4 projects was completed as a principal investigator as he has registered 14 patents along with the co-investors and 6 patents has been granted. Under his supervisions, 11 PhDs was completed and 6 of them are pursuing. His area of research includes development of sustainable material for structural application, micro-characterization of concrete machine, and machine learning. He has received 17 awards, including the most esteemed award of Vishwakarma Award by the year of 2018 by Planning Commission of India, New Delhi. Best Faculty Award in the year of 2017, Bharat Ratna Mother Teresa Award by the year of 2018, and Dr. APG Abdul Kalam Gold Medal Award by the year of 2015. The Indian Concrete Journal honored him by Outstanding Young Concrete Engineer. With this short introduction, I will request our today's chief guest to take the session. Sir, Panlichami sir, now the session is open to you, sir. Sir, participants, before start of the session, we will have a short photograph. Kindly switch on the camera. All participants are requested to switch on the camera to have a short photograph session.
Over.
So just a minute, sir. Yes, sir. Now the session is open to you, sir.
Yeah, thank you, Dr. Bari.
Thank you, sir.
I can share my slide now.
Yes, sir. You can share your slide, sir. Participants, thank you very much.
Dr. Bari, you can see my
Yes, sir.
now?
Yes, sir. Yes, sir.
It's moving next page.
Yes, sir. It's moving, sir.
Fine now?
Fine, sir.
Okay, fine. Thank you.
Thank you, sir.
Yeah, good evening to all. It's a very good evening to all together here for the disaster risk management, analysis and mitigation. This program sponsored by Atal AST. So I'm very happy to share some idea regarding that fluxural fatigue behavior of fiber reinforced concrete for the risk reduction. So the little my topics related to that risk reduction management, not a management, risk reduction only. So that way I want to claim. So if we end up this presentation, you maybe feel till. So these are the kind of technology also available to escape from the building for the any disaster or risk, something kind of things. Today I want to talk about that fluxural fatigue behavior. So today I coined the new word is called as a fatigue. So most of the people highly aware about that. What is mean by fatigue? So before that, most of the people aware about that fluxural. So the beam or any member is subjected to transverse loading. It's become as a fluxural. So in case of the fatigue load also acting on the member, so how it's behave? So what are the risk will be happen due to the fatigue? So how to rectify these kind of things as a engineer? So this topic I want to talk about today. The fatigue is nothing but the repetitive load acting on the member for the long run, that is called as a fatigue. Right? Different failure, you know that. In case of brittle failure, ductile failure, right? That kind of one more failure is there, that is called as a fatigue failure. So what is this? What is importance of the today's scenario that we want to take elaborately? In this presentation, first I will give one or two slides introduction about that what is mean by fatigue, how do you calculate the fatigue, then how to quantify the fatigue, and what will happen if not consider the fatigue. Then again, you slowly are enter into in our system. In case of fiber reinforced concrete, where you are using most of the field, if it is use the fiber reinforced concrete, so what are the theories there? What is the basic mechanism of fiber reinforced concrete? So continuation of that, what way I want to test this kind of fiber reinforced beam or column, whatever it may be, subject to the fatigue, how it's failing. These are the overall presentation of my topic. Next, let us, the fatigue was discovered when several investigations noted that bridge, railroad components were cracking when subjected to repeat loading. So this is the very, very important one. Repeated loading. Continuously apply the load. So continuously apply the load means up to the what stage we can apply. So when it will continuous, it will happen. For example, you can take sustain curve. Or load deflection curve, whatever it may be. Sustain curve, you know the curve, it looks like this. For example, only I'm taking like this. So this is the, we know the yield point, upper, lower, ultimate, breaking. This is the breaking. Okay, no. So you cannot give the load up to this. Correct, no? So if you give means what will happen? It may not come back to original position. So what is it, our terminology? Subjected to repeated loading. Repeated loading. So you can apply the load up to this, what will happen? It may not coming back to original position. You cannot get the repeated loading. It may be break. So most of the our static test and all we did like this only. Like this only. But in case of fatigue, something different, more or less equal. For example, I can take this graph like this, can strain the stress. So within this, I can give more number of cycles. For example, 1000 cycle, 10,000 cycle, 2000 cycle within this. For example, I can take this is the Y yield maximum. This is the yield maximum. Suppose I can take consider some stress here. That is a some stress or some stress I can take up to here also possible. So within this limit, within this limit, so this is the minimum stress, this is the maximum stress. In between, I will increase the stress. So some percentage, other percentage, or constant stress, I'll give the repeat loading. Corresponding load I can take, and I'll give the repeat loading with the different cycle. That I will explain later. So this kind of load will act. So what will happen now? The structure tends to failure. So this I want to take elaborately today. Fatigue is caused by the repeated application of stress to the metal or material or structure. It is the failure of metal by fracture. So another is fracture. Okay, failure different, then brittle is different, fracture is different, right? It is the failure of the material by fracture when subject to the cyclic stress or cyclic loading. The fracture occurs suddenly with and without warning. So we cannot predict. So what is the warning and all? For example, you can take RC beam, you can have some crack at the bottom, then you may let you know. So this maybe failure will happen, escaping from the building. That kind of things. But it may be suddenly failure or may not be failure or with warning or without warning also possibilities there. There is a very little gross plastic deformation associated with the fatigue failure. So it's a brittle in nature. How it's mostly the metal became as a brittle in nature. Then the load is acting repetitively. For example, you take the beam column joint also. How it's failure means due to this brittle only. Beam column joint is failure brittle only. For example, like this. So I can apply the load like this. I can apply the load opposite direction. So we can get that energy here, right? It exhausts this energy greater than this. What is the shear capacity of this member? It's become as a brittle in nature. Brittle nature. Same kind of things happening in the geological movement of the plates also. Same kind of theory. For example, right side. These are the some examples. The failure due to the fatigue loading. So what is means here means suppose this is the suspension cable bridge. Suspension cable bridge. It's we designed this structure for wind load also. Wind load, but we are not designing this any fatigue load. So wind load means the load is greater than the capacity of this structure. It's maybe failure. That is a different. But within the load itself, it's repeatedly acting on the structure. It tends to fail. So this kind of failure was observed in the previously in the bridges also. This was collapsed and railroad bridges also and aircraft. That is the mostly first this terminology start from the aircraft. What are the projection? It's available in the aircraft. The air is goes in this direction. Air goes this direction. So these member are any projected portion. It's get the n number of cycling load with respect to the short duration of that time. Start duration of the time. So if the material is subjected to undergone the repeated loading, the failure will be happen. So we want to avoid the failure. We want to introduce new kind of material. From this, you can reduce the risk due to that natural calamities. That is a major ideas today. Then fatigue is an important from of the behavior of all materials, including metals, plastic, rubber, etc. Example: door spring. Door spring. So we are always calling about the moment equal to zero, so nothing will happen. But the door spring repeatedly apply that load, it may be failure. Aircraft wings are subject to the repeated loads. You can obviously understand. Then the aircraft is there in the cross section. The wings is too long like this, like this. Due to this self-height, it moves up and down. And with respect to the pressure difference, it's move up and down. So how many times it moves up and down? So where it is a failure happen, it maybe can happen here or here properly design the structure, it's fine. Otherwise, it's maybe failure will be happen. So this is some typical example of fatigue. For example, you can see this one. In case of ductile failure means the two material, for example, two material like this, it's maybe yield this kind of things. Then finally, a failure will be happen. But this is the ultimate load, is correct now, or failure load. But here, within this yield load or somewhat above the yield load itself, its failure will be happen. Sudden failure will happen. We couldn't find or couldn't recognize also. That is a major drawback of fatigue. Then these are the some example of fatigue life of the structures. The aeroplane, airlines of flight 243. You see the situation. So the load is act. This aircraft. Due to the repeat loading, this aircraft was failed. That torsion spring failure. Suppose here also, I'll give the torsions to that our spring for that in case of helical spring or it may be leaf spring. So we are thinking about we are giving the load within the limit only, but due to this continuous loading, the failure will be happen. Okay, this is kind of fatigue. So another one is we are thinking about the fatigue happen only the load. So some temperature also important phenomenon for the failure of fatigue. Then one incident was happened that world most of the people are aware about that. The collapse due to the rise in temperature from minus 70 degree to 5 degrees 5 degree in 2 days. The fatigue crack is near the manhole. It may be blasted that manhole entire area. It may be under risk. So these are the some live examples of fatigue. Again, most of the people are aware about that. Is correct now. In that why this aircraft opening it's maybe oval in shape. Oval in shape. Why not rectangular in shape? Right. Right. So in case of this shape aerodynamic model is correct no? This the wind is comes like this, it's go without disturbing of aircraft. Similarly here also, suppose I can put any kind of rectangular kind of things with the sharp edge, this corner have the more stress concentration. So it's maybe failure happen like this. Instead of this, we put this kind of oval in shape. That's why most of the aircraft design like this instead of square kind of things. So lot of theory you need. So how it's the forces act and what is the problem and all we want to know. Then introduction to fatigue. So how I can classify the fatigue? The type of fatigue, number of cycles and amplitude. Number of cycles and amplitude. For example, you may be asked where it is application in civil engineering is correct, no? So you take the bridge, right? So the load is applying or vehicle is move on the bridge. The load is within the limit only. We design the load for example more than 5 kilometer per meter square or 10 kilometer per meter square, but less than that only. But due to this fatigue, it may be failure. That is a typical example of example is highway bridge and railway bridges also. Right? So with respect to the type of fatigue, number of cycles and amplitude, one is a high cycle fatigue, another one is a low cycle fatigue. High cycle fatigue, another one is a low cycle fatigue. The stresses and the time is really varying. Is correct. Suppose you can see this figure. See this figure. So here I told you, the S max, that is the stress max, stress minimum. So cycle means you start from here, then you'll go here and coming back. That is called as one cycle. This is called as an amplitude. Okay, two parameters we want to consider here this analysis. What is the ratio between S max and S minimum? S max and S minimum. Another one is number of cycles. Number of cycle. Number of cycle. For example, you fix this S max and S minimum. It's a very minimum. Very minimum. It take more number of cycles. You can fix that S max. For example, my yield strength of the specimen or breaking of the specimen, for example only. For example, I fix this is S max. So this is the yield point, is correct, no? Ultimate yield point. For example, Fy. I can take the F max is Fy. Then F minimum I can take around 50% of this Fy within this stress. From here to this stress, I can apply means it's immediately failure. Otherwise, I can take this like this. Curve is there. Don't consider that one. Consider this. I'll fix here. Another one is here. This is the minimum. This is the maximum. It take more time failure. This obvious is correct. So I can fix this load is here. That is a S max here. Then S minimum here. For example, this point. S minimum here. The more largest deviation of stress is there within 1 or 2 cycle itself, it tends to failure entire structure. So if where it is this stress and cycle is important, you may be little bit aware about this, correct? So here you can give this more number of S max is minimum, S minimum is the minimum this in the within this kite means you can get more number of cycles. More number of cycles. Now increase the amplitude. Amplitude means what? So amplitude is nothing but what is the height in that x-axis. This is the amplitude. This is the amplitude. So if you increase the amplitude, what will happen? You're using the maximum yield stress. So amplitude also is matter, right? So here with the number of cycle, we can classify high cycle fatigue, low cycle fatigue, high cycle fatigue and low cycle fatigue. So high cycle means like this, immediately feel more number of spacing between these two small. Then low cycle fatigue, some machinery and all, it's failure low cycle fatigue, like this only. Like this one. So you may be asked, sir, they may be this fatigue nature, it's only the sine curve or cos curve, whatever it may be. So this is the standard one. Random also possibilities there. The amplitude also is varying. Then cycle also varying. Then another one is the once you know the cycle and amplitude, you can define the frequency. Frequency is also varying. Sometimes the frequency is different. Sometimes frequency is other one. So that's a lot of complication is there in that fatigue. On this amplitude, completely reverse cycle of stress, unsymmetric cyclic stress, irregular random stress. So completely reverses cyclic of stress. But for example, in case of previously we occurred in this area, that is the beam column joint, we given that heavy fatal high cycle fatigue test. So I can apply the load here like this. Then it tends to, for example, I can take time versus deflection. Apply the load, it's maybe failure like this. within the 1 or 2 cycle itself. 1 or 2 cycle itself. I can change this amplitude of this loading or the frequency of this loading. The behavior is something different. Okay, now. So these are the things we studied in that statically. Now we are moving for the fatigue life of the structure. Then seismic stress and symmetric stress cycles. So here upward cycle and lower or reverse cycle same. Like this, here it's same, here also same. Right. Sometimes we cannot give this exactly for that x max equal to s minimum. Sometimes my graph, it may be greater in that above the horizontal axis, less in below axis, like this. So this is not a symmetric, is right? See here. Right. That kind of things also will go. Otherwise, what will happen? No, suppose I can go for the minimum as zero stress. Again, I'll come to that zero stress. This is the maximum. This is not exactly practical relevance is there. Then another one is a random. This is in case of vibration and all, which comes to this category. In that random vibrations, you can see the stress level is there. No, so this is not a symmetric. Is correct. So you can see this is not symmetric with this, right? This is not symmetric with this. Here, the more stress is in the above the x direction, above the x. The below the x is very less stress. Sometimes less stress below the reference line and above the reference is very, very less. So this is called as irregular and random stresses. Now you can come to the conclusion where you can get completely reverse cyclic of stress, where it is the asmic cyclic of stress, where it is irregular random stresses kind of things. According to your convenient, according to your field problem, you may be apply these kind of stresses. So this is the very basics on introduction about that fatigue. So what is this? What things you will learn from here means the consider the stress and response curve from the fatigue test of the specimen, as shown in figure, this figure. When the strain is increased from 0 to Emax, 0 to Emax, the stresses also increased from 0 to sigma max. You can increase the stress as well as increase the strain. What way? Either way you can do it. So this is here. One is the strain, another one is stress. For example, you can know about this second figure. I can draw the one line. So this is the epsilon minimum. This is epsilon max. Similarly, what I explained in the previous slide, I can explain. I explained about that. What is the maximum stress? What is the minimum stress? We can fix it. Here we can fix that. What is the maximum strain? What is the maximum? So minimum strain also you can fix. When we unload the specimen from the strain E max to the E minimum, the stress strain curves follows the unloaded line and the stresses is decreased from sigma max to sigma minimum. You know that. Finally, if we reload the specimen from E minimum to epsilon minimum to epsilon max, the stress is increased from 0 minimum to 0 max. So these are all the things within the failure load. You cross the failure load means you cannot get again original position. Cannot get original position. So this is a very interesting part. This is called as a hysteresis loop. This is another area of research. Why I can get less area? Sometimes I can get more area. Why it's maybe curved in nature? So why it may be end here? So why? How it comes back to original position? Then how it's pick up the next cycle? Next cycle, up to n number of cycle. This is another thing. So here each cycle you can calculate what is the max or minimum kind of things. Similarly, we may be our, may not be our. some figure where some specimen you can get millions of cycles. For example, steel and all get that millions of number of cycle, but concrete and all it's very less number of cycle, and the stresses also very less. That is a high stress test only we can do. So this is the fundamentals of behavior. Then nature of the fatigue process. Sir, what will happen if the fracture, sir, fatigue will be acting on any member means? So what will happen means if the repeat load acting here, first the crack initiation will be happen. Initiation of crack will be happen. After that, the crack tends to propagate. Propagate means how it's extended inside of the member kind of things, right? For example, I can take the one beam kind of things. I apply the load, tends to crack like this. So next is they propagate the crack like this. Again, it's maybe like this. This is called as the propagation. 1, 2, 3, and all those things. So this is the crack propagation. Finally, fracture. So you have a very good opportunity here. How I can monitor crack propagation, how its crack tends to propagate for different material. For example, I'll give one clue for maybe some researchers very useful. Suppose I can take the concrete with reinforcement alone, plain concrete with reinforcement. So how it's crack, it's initiate, how it's propagate, the where it is propagate, so how many cracks is developed. This is also very good study. And otherwise, I can take one more option also. If the member is there like this, we can apply the load, load, then apply the load. It's not easy immediately, it's a crack. Correct, no? Some load, for example, 10 kilonewton, 20 kilonewton, 30 kilonewton, 40 kilonewton, etc., etc. Some load, the crack tends to start. That is called as a crack initiation. Okay, once initiated, again apply the load, right, with the cyclic load or non-cyclic load and all those things. The crack tends to propagate. That is called as a crack propagation. Other one is the final failure. This is the sequence of nature of fatigue process, right? One is the crack growth, another one is the crack propagation, other one is the failure. So how this crack it moves, how it's propagate and all, that is another area of research. These are the things is very useful for the RC design of the bridges, right? So what we want to improve, these kind of things we want to see in the elaborate manner. Yeah, prediction of fatigue life. I want to like the fatigue life. For example, you may be asked, sir, I'll give one material to you. This may be withstand the fatigue load of around 90% of yield load. How many cycle it's may be withstand? We can calculate. We can calculate. Sir, my strain of the total strain of my material is 0.02 percentage elongation. Then up to what elongation I want to go? With respect to um, uh, a number of loads. For example, you can take one tendon in the previous concrete member. Right? So the tendon embedded in that concrete. So we apply the load to that concrete member. The tendon subjected to cyclic loading or repeat kind of loading. Right? So what load or which elongation this material tends to fail? Either we fix the elongation or we fix the stress. So each material have the elongation is correct. So within the elastic limit only we can apply this. So exceed that means we cannot come back to original position. Within this elastic limit itself, we can apply this repetitive stress, repetitive strain. So it's maybe failure. That is called as a fatigue life. Then The engineers have to use the few methods to determine the fatigue life of the material. One is the stress life method. Already explained. That is, you consider what is the stress maximum, the stress is minimum. From this, how many cycle the material withstand kind of things you can predict. Another one is strain life method. Here we consider the strain diagram. Is correct. Another one is crack propagation. Crack propagation. This is also a very interesting area. For example, you can take the concrete specimen also. Concrete specimen like this. You can cut this specimen or not, don't cut. Apply the load, okay? Apply the load. After the crushing, you take this part, some part. For example, assume this is the concrete cube. Apply the load like this, like this. The failure maybe most probably happen like this, most of the time. Okay. So you take this portion alone outside. This portion only take outside. You can see in the top, or in case of in that this view, this direction view. Okay, you can get some projections. You may be seeing that field test is correct now. Like this, we can get huge number of projections or some plane. For example, we have one plane here, another plane here, another plane here, kind of things. It's like you can, looks like a diamond stone. Correct? We have the different axes. So it's failing. So you maybe take on a project also possibilities there. What is the projection of this? For example, I can take in the cross section where it is the projection. You can measure it. So with the where it is the cut, where it is the weakest portion and all, you can find that is a very good study. That is called as strain life method. Another is a crack propagation method. This is a crack propagation method. Another one is probabilistic method based on the either life or the crack production. So we have the huge data. So where it is a possibility of failure, that is a probabilistic approach. So you can solve the problem. So through these three methods, we can predict the fatigue life of the structures. Among this, so the first one and two, it's a little bit fine. Third is quite difficult. Then parametric approach is mathematically you can play it. Then what is the minimum machine is required means strain controlled machine or stress control. We are using the stress controlled machine is laboratory for the conventional things, but this we need a strain controlled machine is required. Automatically stress also control. Otherwise, actuator you can use. That is not a high frequency actuator. Low frequency actuator you can use. Then you can perform some test also possibilities there. Then the stress life or SN curve. So usually we call it as SN curve method. Another one is nothing but strain life epsilon n method. Epsilon n method. Basically, what you find here means number of cycle to failure. Number of cycle to failure and the stress amplitude. For example, Tamil people maybe know about that. One joke is there, no? Vadivel. One guy slapped to Vadivel, right? First to one or two slaps, he is never crying. He says, Vana. After one more slip, Vana. One more slip, Vana. Aludruvan. After that, automatically, it's water is come down from his eyes. So that time he was yielded, is correct? No? Yielded. Similarly, how many number of slabs he may be withstand? Similarly, how many number of cycle this material withstand? That we can plot it number of cycles with respect to stress amplitude. One point time it may be failure, that is called as a failure stress. So these kind of things we want to calculate. This and other mathematics. Why up to this straight line, slopey line? Why after that straight line? So what is the slope of this? And all those things you can play with mathematics, right? From this you can calculate what is the stress life SN method. Another one is a strain line life epsilon and n method as the possibilities there. So this is the two methods, simple method to predict the fatigue life. In addition that, lot of method available to find the stress life of the material. So up to this, you learn something regarding what is meant by fatigue, what is the importance of fatigue. So where it is a fatigue applicable in the civil engineering field, particularly bridges and the dam structures, or where it's getting the load repeatedly, for example, railway bridges, railway tracks, or it's a building, it's a tall building subjected to the wind and some machine load repeatedly acting on that particular floor, some vibrations from the other machines and all those things, some typical example of fatigue. Yeah, basically you have one more dot I think is right. What is the basic difference between dynamics and a fatigue? Is correct? More or less same or different? Dynamics, structural dynamics most of them will study it is correct. And some people studying about the fraction also is fatigue. So structural dynamics, the frequency is more, right? But here frequency is very minimal within the stress only we are dealing that. So that is a difference between the dynamics and the fatigue. So up to this we learned. Sir, why you put this fiber reinforced concrete here? Somebody maybe have some doubt for this, correct? So why? Because so entire life of the structure with respect to the stress is correct, no? Stress. So now the research is not limited only to the elastic in nature, is correct. Sometimes I am ready to go for plastic. Sometimes elastoplastic. Sometimes I go for up to some level. That is in case of yield, not a yield, after breaking, after peak also. For example, can take this graph, x-axis, for example only, x-axis I can take stress, y-axis I can take, sorry, x-axis strain, y-axis stress, or it may be deflection, or it may be load I can take, right? Where is this role of this kind of measurements? If within this means not a big deal. For example, this is the yield, no, up to this not a deal. Someone will go up to this is good deal, good deal. Someone is go up to this little risk. Someone even take the risk, they will go up to this also. This also is there, right? So up to the yield multiply by some factor, we can use this area only in case of structural system because of our safety is important. Safety is important. Sir, this is itself, it's a fine. Why you go beyond this? What is the need? You go beyond this. You have some doubt, is correct, no? Why? Go like this. So this area, it's give the intimations and tends to fail you from this area to this area, save our people. Save our people. That's why this series is very, very, very important. Now, the research is going on how to improve this particular area because this is a very less area when compared to the blue shaded area. Blue shaded area. So why not concentrate more here? Maybe sometimes maybe share here also possibilities there. So what is the beauty of fiber here means? Fiber here means it improves the ductile behavior. Some fibers it maybe improve the initial load carrying capacity or some short-term failure kind of things like a shrinkage, that kind of things may be taken care of. Some fiber, it's maybe work beyond this yield or upper or breaking of this point. Okay, no. So I will see that. What is that? What are the materials used kind of things. Now, this area, it's a nowadays is a very keen research. This area is related to fatigue. So how it's this fiber is a contributing the how these kind of fibers so contributing the fatigue life of the structures we can see elaborately. Now, in basically the fiber to improve tensile capacity, more energy absorption, more residual strength, and crack arresting capacity. So these are the things most of the people are aware about. That is correct. Improve the tensile capacity. So where we are using the tensile capacity? So I think IS 456 nowhere using the tensile capacity of the material. Even we are studying about the tensile capacity. So you have severities uses. For example, you can go for the pre-stress concrete design. So you can use some tensile stress. Is correct. So you can use some tensile stress within the limit. It's possible. So that is that beauty of pre-stress concrete design. So we can use some tensile stress, some certain limit, but 100% utilize the compressive stresses. That is the pre-stress. So that time we can use some fiber, can improve the tensile capacity and more energy absorption. So these kind of things is very useful for the risk reduction or escaping any disaster failure. For that purpose, we can adding that fiber. You can get that more energy absorption capacity. Then more residual strength. This is also important. The how much strength is stored this material, that is very important. So still we have the n number of theories available, n number of theory available to calculate the residual strength. Each theory, each code, they have the different approaches that I want to take elaborately today. So how you can calculate residual stress, how this residual stress affect the strength of the material, and also we can study elaborate manner. Then what is the application and all? I don't need to explain. We have that huge applications. Again, another 1 minute I will take fiber reinforced concrete mechanism. So what is the mechanism? Why I use this fiber in the concrete? So the basically we have that two crack. One is that micro crack, another one is a macro crack, right? One is a micro crack, another one is a macro crack. So already told you that the fatigue of the materials is slightly related to the crack. I told you no crack propagation, crack initiation, crack propagation and crack initiation. For example, you can use some kind of short fibers, for example, polyethylene, polypropylene, these kind of fibers. It's the bridge gap of that micro cracks. For example, this is the crack you can see. You can some fiber it's may be oriented. We cannot orient the fiber exactly on the crack. The crack is there. It is the bridging the gap between the two faces. It's holding that nature. It's arrest the micro cracks. Arrest the micro crack. In case of macro crack, you can use this macro fiber or the long fiber. Long fiber means diameter also matter. Length and diameter. It's a matter means length and diameter measurements. That is called as aspect ratio. Aspect ratio. So length also is matter, diameter or cross section also is a matter. So now in the fatigue, first the crack is initiate, then tends to propagate. So the initiation stage, the crack its nature of micro cracks. In case the propagation state, it's crack as the macro. So now it's my duty is I want to add some fiber into the concrete to arrest the micro crack and arrest the macro crack. So what is the uses of this? For example, I can take plain concrete alone, plain concrete alone without any reinforcement. Is that right? This is the crack propagation and crack initiation. You cannot predict very easily, is correct? No? If you apply the load immediately, it tends to break. Tends to break. That is the nature of plain concrete without fiber. For example, you can add this kind of fiber, you can get more number of cracks. More number of crack. It gives some warning to us to escape from the building. This is another important. So what we can understand is this kind of fibers, it maybe reduce the damages of the concrete or any member um, subject to fatigue loading. So now in this topic, this presentation, I taken two fibers. One is a steel fiber, another one is polypropylene fiber (PP) and SF, that is a steel fiber. Now these two fibers is maybe helpful for that fatigue life of the structure. That is just today's presentation. Next one is, these are the some experimental details. Don't worry about this. We can choose one is a hooked end fiber, another one is polypropylene fiber. Rest of things you can, what you like, you can add it, not an issue. This is called as a hooked end fiber. The how it works and all, you know the mechanism, fiber reinforced concrete mechanism. We can that. We use the different combination of fiber also with different fiber matrix proportion. 100% fiber of steel fiber, then 25% is the steel fiber, 75% of polypropylene fiber, then other this is the combination. This is called as fiber volume by fraction. You can see the fiber volume fraction. Why we consider the volume fraction? Why not weight fraction? For example, the fiber, it's may be very very lightweight in nature. Is correct? No, lightweight in nature. So you can take the fiber quantity with respect to the weight. It's take more volume or occupy more volume. So the fiber itself occupy the more volume. That is a bonding between the fine aggregate, coarse aggregate, and all those things. It's very difficult, is right? So for that, we are control the fiber by means of volume fraction. Volume fraction even 0.5, 1, 1.5 kind of things. So here they use this polypropylene fiber volume fraction 0.1 to 0.3 alone. But in case of steel, we can get more. So why this usually this one means a lot of workability problem will arise. In case of more volume fraction will go, I can get some balling effects. So the concrete is not a sticky nature. It's not a flexible in nature. It's a very sticky and very difficult to mix and carry, and segregation happen between that aggregates and that cement mortar and fiber and all those things. For this region, they are using the fiber volume fraction. These are the some properties of material. I don't want to explain much. These are the mix design. Mix proportion is like this. 1 is to 2.95. Don't worry about this. These are the specimen kind of things. Now, before that, fatigue nature, fatigue test. So you want to know about what is the basic mechanical property of the various concrete mixes at the 20 days. So what is the need? What is the need? So we are go for that compression fatigue or tensile fatigue, or it's torsal fatigue or flexural fatigue. Suppose you want to know about that, what is the strength of the material conventional method. For example, we are consider, for example, I go for that flexural strength, flexural fatigue. Today's my topic is the flexural fatigue, is correct? Flexural fatigue means I should know about what is the flexural strength. So for example, normal concrete, I have the flexural strength of 4.33. That is a flexural strength. From this, I can fix what is my sigma max and sigma minimum. Sigma max and sigma minimum and a number of cycle or frequency. Frequency I can fix. For example, I can take 4.33, 4.33. I can use the maximum, the stress level is around 90 percentage, 0.9 into 4.33, 3.89. That is that I suppose I can use zero point 0.9 times of sigma. For example, I can use that sigma 0.9. Then this is the sigma max. Okay. Now I cannot use this stress 100%. I cannot start from the zero, right? So I can reduce from here around 90%, 80% just kind of things. For example, I can take 0.25 times of sigma. This is called as sigma minimum. Okay, one is a 0.9, another one is a 0.25. So 0.9 nothing but 3.897. 3.897. Then 0.25 of 0.9, 0.25 of 0.9 is equal to 0.225. So this is the sigma max. This is the sigma minimum or x max x minimum. So 0.9, 0.25 to 0.9 or 0.9 to 0.25 sigma. Now I can fix this graph. Is correct now? So here my maximum stress is 0.9. The minimum stress is 0.25. So now I fix this amplitude like this. This is maybe symmetric or asymmetric. Asymmetric is correct now. So I can fix this number of cycles, right? So this is called as an amplitude. Again, this kind of things you can solve by means of Fourier series also. Fourier series, Fourier transform analysis, right? This is again how it can solve that phase angle, number of cycles, and all those things we can do it. So I can calculate what is that stress level. Similarly, this is the stress level from 0.9 to 0.25. 0.9 to 0.25. Now from 0.9 I can get down. Okay, dead down is possible. 0.25 I can increase. Possibility is there. Okay, so likewise we can extend this problem in different aspects. Okay, now so you can reduce this sigma max from this minimum or minimum. We can make it as a maximum. So different combination you can do it. So what um, which cycle it's maybe failure you can find, that is called as a fatigue load. So that is the critical stress. These kind of things we want to find. So this is for the only flexural strength. Similarly, torsion, where it is torsion will happen, no? Torsion will happen in that some engine parts is correct now. So for example, this is the torsional shaft, it's a rotating direction. So the stars rotate the clockwise direction, anti-clockwise direction, clockwise direction, anti-clockwise direction. Among this cross section, what is your stress? You can calculate now. So this is the maximum stress. This is the minimum stress. You can fix between these two. You can extend the problem. So this is the basic concepts taken the sigma max, sigma minimum from the mechanical properties of the very concrete mixes. So I can maybe something somewhat understand kind of this, right? So we can go for flexural strength or split tensile strength or compressive strength, whatever it may be. Fine. So modulus of elasticity and all other parameters we can use for this test for other purpose also. For example, modeling and all we need. For that we taken this. Now these are the other properties we consider. Don't worry about this. These are the strength, how it's maybe increase or decreases. These are the some specimen details of the different fibers, how it's failure, multiple failure kind of things. So these are the some mechanical parameters which may be considered for the fatigue life of the structure. Another one is topic is, sir, we fixed this sigma max, sigma me, sigma minimum, and all it's fine. So the reduce the failure of the structure or sudden failure reduce by means of after peak load only. So that part only it's considered. Basically, you are studying that basic strength of material. For example, I can take this again sustained curve. I can like this. So below this curve, no, that you can get that energy. Is correct. We can get the energy, right? If the curve it's maybe more area, you can have the more amount of energy. For example, up to this is the yield, I can have less amount of area. After this, from here to here, you can see huge quantity of areas there. Huge quantity areas there. This area is contributing for the ductile behavior or fatigue behavior of the materials indirectly. So now I want to link this area related to this one. Then I can get two parameters, how it's these two is linked, right? That is called as flexural toughness or flexural indices. So another 10 minutes I can talk about that flexural toughness and the flexural indices also. So basically what is this? Flexural toughness is the ability of the material to absorb the energy and resist the fraction. Absorb the energy, how much energy is absorbed to that external loading or disturbance and resist the fraction. Fraction means it may be break under bending, flexure loads, tension load, compression load, torsion load, combined also possibilities. It is represent the material's capacity to sustain the loads beyond its initial cracking point without sudden failure. So the capacity withstand loads beyond its initial cracking point without sudden failure. In general, the area under the load deflection curve obtained from the flexural test represent the flexural toughness. Flexural toughness. Sir, you have also a lot of question. Sir, some beam is maybe immediately failure. My curve looks like this. Some material goes like this. Some material it's failure like this. So which area I want to take? Yeah, different author they take a different area. So somebody they stopped here, somebody they stopped here, someone stopped here, someone stopped here. Okay, so depends upon that. So different author, different code also mention different aspects. So as engineer, in front of us, we have that good things, bad things, or good material, bad material. We only segregate big, so good material, bad material, or good behavior, bad behavior using our engineering knowledge. So like that, we want to segregate. So what is that? How can choose the best material for our risk reduction. So another one is a toughness index, typically determined from the ratio of total energy absorbed by the specimen during the flexural test to the energy required for the reach the first crack formation. First crack formation. So now you can see this figure also, how this figure is connected. For example, total energy means what is that? Entire total. This is the total energy. Okay. This is the total. For example, I can take T total. Okay. The typical demand is the ratio of the total energy absorbed by the specimen during the flexural test, energy required to reach the first crack. So what is that area of the first crack? First crack may be somewhat here, is correct, no? For example, here. So I can drop this area. Now I can calculate what is the area of this. Okay. So for example only, first crack load or area what kind of, this is called as a toughness index. Similarly, the various approaches is there. One is ASTM 1018, ASTM 1609, ASTM C 1399, JSC CS 209. So all these things is obtained from the load deflection curve. So most of the researchers drawing the load deflection curve for different specimen. So don't stop it. So you can find this kind of toughness flexion indexes, means it's very useful for the further researchers also. So this is the load deflection behavior of fiber reinforced concrete prism. So load is measured and deflection also measured, we plotted here. So you may be asked, what is the role of fiber, sir? Is correct? If you suppose we are not added in fiber, means the graph may be like this, not up to this also. It's maybe like this kind of. So we are talking about that area, correct? No, area below the curve, right? Some curve, the failure point, it may be shifted here. Something here is there, something here, some here. So we want to calculate or go in deep why this much difference is happening between the load and deflection. Why its shift is happening? Due to the microfiber or macrofiber or combined fiber. These kind of things we want to discuss elaborately, so you can get a lot of informations. So whenever you draw any graph, don't leave it like a graph. Then you can explore different way. Why shift is happening here? Why not shift is happening in say above, below? Why sudden drop? You can see this figure now. For the yellow color, we observe the sudden drop is correct. After that, it's maybe steady state slope. What is the slope here? What is the slope here? So why this a deep slope? Why not this gentle slope? So now this is the upward slope up to this, the straight line. Then after each point, this is a downward slope. Why it's downward slope? Why not this figure? It's maybe goes like this. That strain softening effect on this strain hardening effect kind of things, right? That is another area. I'm not talking about that, right? So these are the things want to again go in deep. We can get lot of informations. So Dr. Bari, we have another 5 minutes, sir.
Sir. Yes, sir. We are having another 5.
Yeah, I want to conclude. Is correct, no? Yeah, fine.
Yes, sir. Yes, sir. Okay, sir.
Good. These are the some volume fraction. So from this, we can calculate what is the initial crack, what is the deflection in the initial crack, what is the peak load, what is the corresponding peak deflection, what is the final deflection, and final strength also you can calculate. That is a flexural strength also you can calculate. So what are the parameters you have? You have initial crack load, corresponding initial deflection, then peak load deflection, final load, then finally you can get that what is a flexural strength. Finally deflection we cannot measure, that's why we are not given here. The flexural strength. Using this parameter, we can develop one model. So this is the model ASTM 1019 flexural toughness and the first crack strength of the fiber reinforced concrete. So I already told you, some people taken this energy is found within this limit here itself. Someone is go up to this, someone up to failure they will go. This all that depends upon the author. As per ASTMC 1019, toughness indices is a residual strength of factor determined by I10, I5 factor, I10 factor, were determined by the using the load deflection curve. Now we can calculate that I5. I5 is nothing but area of O A B C I. How we can calculate that is a PF. PF is nothing but first crack load. Okay, del means first crack deflection. First crack deflection. Elastic limit approximate first crack, that is called as a. So we can mark where is a del 3L, 5.5 del L, 15L, then n number of del by 2. Then we can calculate the area. Suppose I want to calculate residual strength R5, R10, number of obtained by the calculating the value of 20 into I10 and I15 minus I15, we can get what is a residual strength. Similarly, we can calculate other parameters with the different methods. AST method is there, Japanese method is there. Some author also developed. So this is developed. The reading developed by means one of my research scholar. She is Stuti BS. She is working under me. We are developing one new method how to calculate the flexural toughness factor. So that way, that part is going on. So due to the time shortage, I am able to complete the entire presentation. Part 2, I will explain in elaborated manner. Any chances there, how to calculate different method is there, how to calculate the flexural index, toughness index, and all the things. I want to conclude my talk today. So what you learn today means what is mean by fatigue, what is importance of fatigue, what is meant by flexural fatigue, right? What is the role of fiber in that fatigue? So how can arrest or how to control the fatigue failure of the structures? What are the methods to predict the flexural index or flexural toughness, so on, so etc. These are the things learned. This is the partial fulfillment of today's theme. So once it's completed, let you know how much the material have the energy. For still, I am given only that load deflection curve one cycle is correct. Similarly, we have that millions of cycle. Now we can calculate that energy. That and all, we need the other high computing facility. Suppose nowadays we have that Python coding and AI, artificial intelligence kind of things. We can write the coding, we can solve the problem mathematically. So I talk only with the experimental observations, right? Similarly, this problem may be extended for that using some mathematical equations like Fourier series, Fourier transforms, and the conformal mapping. Then other kind of standard functions available. You can use some approximate function and all. You can solve this problem in a different way. The problem is common. How we can solve this problem is different method. That is another area of research. So with this, I want to conclude my talk today. I was highly associated with K.S.Rangasamy College of Technology. So today's beloved chairman, Dr. K.S. Rangasamy MJF birthday. So my wishes also. So with this, so I want to conclude my talk. Thank you very much, Dr. Bari and Dr. Ramesh and Professor Ramesh and other faculty members and dean directors and principal of KSR College of Technology. Thank you very much, and my dear participants patiently sitting more than 1 hour. Thank you. So now we have any discussion means we can discuss if time permits.
Yes, sir.
Dr. Bari?
Yes, sir. Thank you very much for your
Yes.
wonderful session, sir, on flexural fatigue behavior of fiber reinforced concrete for risk reduction.
Thank you.
Uh,
Thank you.
we will have a 5 minutes for discussion, sir.
Okay.
Dear participants, if you have any queries, you can able to ask with our Dr. Palnichami, sir. Dear faculty members,
Any question from chat box?
sir, if there is any questions, I will ask them to send to me, sir, and I will directly inform you, sir.
Okay, fine. Thank you very much.
Thank you, sir.
Sir, good
Participants,
evening, sir.
Yeah,
This
good
is
evening. Good
Vijay
evening.
sir from K.S.R. College of Engineering, sir.
Yeah, yeah.
Sir, actually today was your birthday also, sir. Wish you happy birthday, sir.
Yeah, thank you very much, my dear friend.
Yes, sir.
Thank you.
any queries, participants, or any discussion? Sir, I have having only one doubt, sir.
Yeah, tell me, Dr. Bari.
Incorporate this in artificial neural network, sir. The flexural fatigue behavior of fiber reinforced concrete.
Hmm.
Can incorporate
Sure.
artificial neural network in this concept, sir?
Yeah, yeah, possibility is there. One of my BTech student working this area, was incorporating this neural network, sorry, fatigue life prediction using the neural network. That is, we need database only, no. Data maybe 0 or 1. That is more than enough. That data should be realistic. That is the important matter in that ANN. So most of the people doing the ANN, but how much this data is maybe reliable, it should be ensure it. So now the lot of method is there, how to refine the data, how to set the data set, how to set the data points, what the filter technology. Lot of technology is there using that and all. You can filter the data, omitted unwanted data, the more reliable data you can take, unwanted data you want to omit it, scientific way. Then you can get that good result, and you can take only the good result, good result only. You can get that good output. That is not a deal, but you can add some unwanted also inside. It segregate from that you can get the result means good model. That's sometimes that is another area of research. The possibility is there. The flexible betting period using that AI and also artificial intelligence, lot of advancement is there. Possibility is there, Dr. Bari.
Okay, sir. Thank you, sir. Thank you very much, sir. Now, any more discussions, dear faculties? If you have any more discussion, or otherwise, we will move to our next session. Sir, thank you very much, sir. In spite of your busy schedule, you came to us on your birthday and as well as our founder
Yeah, thank
K.S.
you.
Birthday also. Thank you very much, sir.
Thank you. Thank you very much. Convey
Yes,
regards
you
to all. Thank you very much.
okay, sir. Thank you, sir. You can answer, sir. Dear participants, you wait for a few more minutes. The next guest will join sooner. So you can leave, sir, if you need.
Sir, Ramesh sir.
Am I
Dr.
audible,
Ramesh,
sir?
Yes, sir. You are audible, sir.
Abdul Bari, sir. This is Dr. Abdul Bari.
Yes, sir.
Am I audible? Sir,
You
just
are
a minute,
audible.
sir. As a presenter, sir.
Yes, thank you,
Can
sir.
can you able to share the
Yes, sir. Sir, can you tell your number?
just a minute, sir? I will make you as a presenter, sir.
Yes, sir.
So now you verify, sir. Now you are in a presenter mode, sir.
Sir, I think share is in off mode, sir. PowerPoint.
So you switch off your video and share, sir. Once I
Okay.
knew, sir.
Not possible to share, sir.
So just a minute, sir. I will check it.
Sir, I linked in another. Sir. Mobile number.
Just a minute, sir. Ramesh, sir.
Sir, you open. Sir, you open all the numbers, sir. I think I have some other number. My laptop linked with another one
Sir.
number, sir.
Okay, sir. Okay, sir. Yes, sir. I will make it open to all the numbers, sir.
Yes.
Ramesh, sir. Are you in meeting, sir?
Yes. Yes, that one, sir.
So just, sir.
So, Dr. M.J. Gopi Gopes.
Yes, sir. Yes, sir. Dr. M.J. Gopi Gopes. I am seeing that, sir.
Open
Just-
that folder.
So just 5 minutes, sir.
Yes.
Participant, you wait for 5 more minutes. There is some issue in this connectivity. We will sort out soon and we will start our session. Sir Gopinath sir, we will start within 5 minutes, sir.
No issue, sir.
Okay, sir.
I'm waiting for your presence.
Open it.
Participants, sorry for the delay, very short delay in the network connectivity. Sir, Gopinath sir, now you can able to join, sir. Gopinath sir, can you able to join?
I'm audible, sir?
Yes, sir, you are audible, sir. You are audible.
Yes, yes.
Now you are as a presenter, sir. Can you able to share your slide, sir?
Sir, not possible to share, sir.
Sir,
Sir, I already sent to your WhatsApp. Can you share that?
yes, sir. Yes, sir. Just a minute, sir. I will share it, sir. Is the screen is visible, sir? Is the screen is
Yes, sir.
visible?
Visible, sir. Good morning. Sorry.
Just a minute, sir. I will have a short introduction about you. Dear participants, sorry for delay. Now we'll move on to our next session by Dr. M.J. Gopinath. Am I audible?
You're audible, sir.
Yes, sir.
Yeah.
Immediately.
Yeah. A short brief about Dr. Gopinath, sir. Dr. Gopinath, sir, is presently proprietor of the JPG Housing and Projects Private Limited, Tirupur. He has completed his PhD from Anna University and master degrees from Tamil Nadu Engineering College and Bachelor of Engineering from Karmatapati. Dr. Gopinath sir has worked out many projects like Supreme Spinning Mills in Tirupur, Tirupur New Bus Stand projects, Tirupur Cargo Shipping, Balamurugan service stations, and many other projects. He has awarded as a JC past President Avinashi, Lion Club member and director from 1998, Association of Institution of Value member and valuer for bankers and private financiers from 2006, Association of Institute of Engineer member India and Chartered Engineer from 2005, and a renowned structural engineer from 2008. And he has renowned as JPG Construction, that is JPG Housing and Projects Private Limited from 2008, and trainer for more than 50 schools, colleges, and corporate companies. He is awarded as a Best Civil Engineer Award from Tirupur Rotary Club, Best Doctorate Appreciation Award from Tirupur Social Service Trust. He is a zone trainer in JCS and President for Structural Engineering Association of Tirupur District, and present worked as a faculty member at Teja Shakti Institute of Technology at Karamathapatti, Coimbatore. With this short introduction, I will now welcome our today's chief guest, Gopinath sir, for his presentation. Sir, Gopinath sir, the meeting
Yes.
is open to you, sir.
Good evening, everybody. I think this is a right time to talk with you. and a great opportunity to me. It's a milestone for my career. I like to introduce myself. I am Dr. M.J. Gopinath. I have two companies, JPG Housing and Projects Private Limited and BPG High Tech Valuers.
So the voice is not clear, sir. There is some sound.
Sir, audible, sir?
There is some noisy.
So, one minute.
Yeah, now there is no noisy, sir.
Okay, sir.
The noise is there. Still noisy is there.
Sir, is it okay?
Yeah, now okay, sir.
Okay. Hello, friends.
Yes, sir. Audible, sir.
Yes, sir. My topic is experimental investigation of precast structure under cyclic earthquake loads and recycling earthquake loads. Next. Sir, I am audible? Hello?
Sir, audible, sir, but there is a noisy sound. Is there still?
1 minute, sir. 1
minute, sir. I will check from my
Just
side.
open that MJ Gopes.
Sir, MGM Gops, that's only I have opened, sir.
Sir, is it okay?
Yes, sir. Sir, I have allowed mics and camera for all these attendees. Now it is okay, sir. You can. Sir, I think your screen is visible, sir. Now it is okay, sir.
Okay.
Yeah, okay, sir. Now it is okay, sir. Clearly okay, sir. Sir, audible, sir.
So 1 minute, 1 minute. Now, sir?
Yeah, okay,
Hello.
sir.
Okay.
Okay, sir.
Yes. Sir, next slide, sir. Can you move on to the next slide?
Just a minute, sir.
Yes. Today I delivered a small lecture about the precast structures. I think it is a very important part to our Indian development because we are highly populated country. Presently, we have no proper infrastructure compared with other countries because all the in tallest building is in Dubai, big mall is in Iran, and Iran, sorry, the world largest harbor is in Shanghai, world largest airport is in Los Angeles. So, world largest population country is India. So, what kind of infrastructure we need presently? Definitely, we need this precast structures. That's why I gave lot of effort to this research and brought lot of things to your knowledge updation. So I'm a practicing engineer. So if anything wrong, small things, sorry for the inconvenient. So the previous, can you go for previous slide, sir? Yes, my content is introduction. Presently, I delivered introduction, literature review, objective and scope analysis using ETABS, test setup, experimental observations, finite element modelings, conclusion, reference, list of publications. What's my concept? My concept is how to convert and how to translate the conventional to precast. This is the main concept. What kind of earthquake occurred on our zone? What kind of failures occurred on that conventional structure? Same manner, the load translated to the precast structure. So I compared that moment after I got lot of details from that research. First of all, I tell about introduction. Next, introduction. Prefabrication is advanced and up-to-date method of reinforced concrete construction. So it is a very fastest construction in the world compared with conventional method, 3D printing, etc. etc. So this is mandatory for our Indian country development. So next structure is united into members or precast in factories equipped partially, particularly for these purposes. They are then shipped to the base where they are to be used and hoisted into the final places. This is a joint method. The first one is core slab. Presently, core slab is prepared some other places, and columns, beams are prepared in some other places. Like that manner, the precast construction industry is going on because it is very economical one. This is a joint method. The column contains every part. Corbels is there. Compared with conventional method, it is a small difficulty to replace in the sites. So definitely the corbels need for this proper construction. This is the model for joint. Next, sir. Introduction. Type of prefabrication. We have two type of prefabrication. One is plant prefabrication. Next one is site prefabrication. So the plant prefabrication is controlled one. We have lot of machineries and hydraulic presses, so we will get proper elements. In site prefabrication, it's very difficult to work, but transportation is nothing. So it is very economical one. So two prefabrication method is there. One is plant prefabrication, next one is site prefabrication. Next, sir. This is plant site prefabrication. Already I told all those things. It's a simple one. You understand all already. Next, sir. Advantages. What kind of advantages in prefabricated structures and prefabrication work? It's a modular one. It's a strengthened one. Durability. It will take long durability. It will give long durability. More than 70 years it will withstand in the field, no doubt about it. Efficiency is very high compared with conventional frame. Efficiency is very high because we are used M20, M25, M30, M35, like that manner. We give a lot of big quantity of concretes and high grade concretes, so it is efficient. It will give more efficiency compared with conventional structure. Speedy construction, low maintenance cost, quality finishing. We don't want any frosting for the precast elements. Next, advantages of prefabrication. Total saving of materials, multiple time using the same shuttering. This is a very important point. We don't need any shuttering on that site. If you will construct with the help of prefabricated elements, you don't need any shuttering materials. This is the main point for this research. Better accuracy of workmanship, requirements of manpower decreases, allows the establishment of lighter, more beautiful and slender structures you will get. Next, sir. Next, precast applications. Presently, we are constructing residential buildings, factories, educational buildings, water storage tanks, sewer systems, many other structures. So this is the precast applications. Presently, water tanks, septic tanks, drainages are using precast elements. Next. This is the basic joint. If you will go for precast structure, joint is very important. In this research also, we focused only joint part because everywhere we will get some problem in joints only. Even conventional method, the joints are failed. If we will go for earthquake load, some other load, if we will give on that structure, the first and foremost failure occurred in the joints. So we are researching the joints only. Next. Next, sir. Sir, next. Sir,
It's not clear, sir.
please move on
It's
to
not
next.
clear.
Sir, I am audible, sir.
Now audible, sir.
Hello.
There is, yeah, now audible, sir.
Okay. Sir, audible.
Still there is noisy sound, sir.
Sir, nearby
The
mobile is
headphones
there, sir.
போட்டிருந்தீங்கன்னா
I think
situation,
something
sir.
problem with the.
கரெக்டா இருக்கும். அந்த மைக்ரோஃபோன் ஏதாவது ப்ராப்ளமா இருக்கும் சார்.
Is it okay?
Oh,
okay,
sir. பேசுங்க சார். Yeah.
Sir,
Now it is
okay,
okay,
sir.
sir. You can proceed, sir. Now it is
Okay.
okay, sir. You proceed, sir.
Okay. This is the framed structure, precast structure. Next, sir. Next. We have two type of precast structure. One is wall bearing precast structure. So next one is framed structure. Next. This is we are using wall panels. After constructing this type of structures, it's very economical one. It's a limited one. If we will go for wall paneling, up to 4 to 5 floor is advisable. This is framed structure model. Next. Next, sir. Sir, next.
Now it is visible, sir. Yeah.
Yes. After constructing, after using framed structure, this type of structure you will get it. Next. Behavior of prefabricated structures. All over the world, it has been reported that moment resisting frames and structural walls incorporating precast concrete elements have performed poorly in earthquakes. The main point, it is believed that the poor seismic performance in these precast frames and walls is due to brittle, non-ductility behavior of connections. Details between the precast concrete elements, inadequate detailing of components, and outdated design concept. That's why the precast joints are failed in the earthquake moments. This is the failure pattern in earthquake times. This is the factory building. This is residential building. See that red color round part. Only the joints were failure. If earthquake occurred, first and foremost point, the joint only failure. So we took that joint part to research and got lot of advanced techniques for the joint failure prevention. Next. These are also prefabricated earthwork failures. Next, literature review. We searched all over the world in precast structures and got a lot of information from the literature reviews. Next. 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 Yes. So finally, we come to one conclusion. The present study focus on performance and behavior of prefabricated frames and their connections efficiency subject to lateral loading. The following are the objective of the present study. The characteristics are the ingredients going to be used in prefabricated elements to find out optimum mix proportions of concrete going to be used in prefabricated elements, to study the properties of concrete going to be used in prefabricated elements. These type of works we did in this research. Next. The performance parametric study and analysis the frames by using extended three-dimensional analysis of building system with the help of ETABS and ANSYS. We were using ETABS and ANSYS for analysis part to find out efficiency way of prefabricating the elements for frame, to suggest the effective type of connections, to find the load carrying capacity of frame, to study load versus deflection behavior of different connections at different joints, to investigate the mode of failure in each model. These are our objectives. Next. Our scope is to maintain good quality of joints. The main scope of the present investigation is to study experimental and analytical behavior of prefabricated frames and with different bay and story under lateral loading condition. First of all, we come to a conclusion and planned how to find out these type of failures. So that manner, we designed single bay single story, 2 bay 2 story in with infill without infill, and 3 bay 5 story with infill without infill. So we got lot of information from that frames after we designed that joints. So next. The investigation is required. So 1 minute. So 1 minute. The investigation is required because the number of advantages that the prefabricated method of construction possesses compared to that of other construction methods. The scope of the study is to assess the character of raw material and finding the optimum proportioning of concrete. The scope also includes that the parametric study with the help of ETABS before experiment work, and that the experiment work is verified with the help of analytical method. First of all, we planned for design the frame. So we use the ETAP and ANSYS, find out the result. Next we go for conventional method. We got the result from conventional method frames. Next we designed that joints after we went to that prefabricated methods. Materials property. We used heralded. So next. These are heraldite materials property. Next. We are using a glass woven roving mat, GFRB material. Next, for the joints. These are material property for the fiber. Next. model, analysis, design and detailing, conventional and precast frames. Next. This is a straight away we go for research part. This is a single base, single story. Before multi-story structures research, first of all, we analyze single base, single story. So we prepared 3 type of single base, single story. The first one is conventional method joined single frame. This is the model. Next. This is the detailing of steel reinforcement 1 by 1 story, single base, single story frame. We are using 4 number of 12 mm bar for column, 4 number of 8 mm bar for beam. This is a conventional method for single base, single story. The basement is 10 mm dia. This is the model for 2 by 2 story frame. Next. We designed the frame with the help of ANSYS after we arrange the reinforcement like that manner. This is the foundation. Foundation also precast. We brought the result, conventional method from some other research work. We prepared precast. We prepared precast elements for this research work. This is the joint pattern. In beam sizes. 1 minute, sir. The column size is 200 by 100. The beam size is 150 by 100. This is the dimension for the 2 by 2 story frame. Next. Model for 3 by 5 story frame. This is the model. The column size is 0.3 by 0.6. The beam size is 0.3 by 0.45. The total length is 10 feet. 10 feet by 8.5 feet. 3.65 by 2.47. Next, sir. This is the reinforcement detail. First of all, we using E-taps and find out the failures. After we design that reinforcement, which part is weaker, at that place, we give good quantity of reinforcement for the conventional method. This is the conventional method reinforcement arrangements. Next. Connection detail. So conventional is very, very easy. We know all about the joint detailing in conventional method. This is the precast joint detailing. The connection of beam and column edge contains 25 by 25 by 5 mm equal angles, and that the angle tied with the help of 6 mm thick welding. The each precast element have steel tubes. It acts as sleeves. The size is 12.5 mm dia. Those sleeves tied with MS bolts. Finally, total connection gaps were filled with grouting epoxy. We used three type of connections in that part. The bottom of the column is the bottom of the beam is corbels. We prepared the corbels for the special reinforcement arrangements. So after we prepared welding and bolting and grouting method for these connections. It's I think it's a fixed connection. Next. Sir, next. This is the bolted connection detail. When connection is done through the bolt 12 mm diameter, as per IS 800 2007, diameter of bolt hole is 13 mm. Consider the pitch of 40 mm as per IS 800 2007. Strength of the bolt is single shear is VSB is 26.05 kilonewton. As per IS 800 2007, strength of the bolt is bearing is VP equal to 23.376 kilonewton. Use one number of 4.6 grade bolt. Strengthened bolt is 23.37 kilonewton. Next. The maximum load carried by 3-bay and 5-story precast frame 253.7 kilonewton as per analysis. The maximum force required to transfer force at the topmost first connection is 253.70 kilonewton per 6 equal to 42.28 kilonewton. We shared that one. Welded connections. An angle section, we used a welded connection also. An angle section of 25 by 25 by 3 mm was selected to transfer this load. The area of angle section is 141 mm squared. Design strength of weld is 22.27 kilonewton. The weld strength and connection equal to, because two sides we are using two welds, so 2 into 22.27 equal to 44.454 kilonewton. The weld strength is 44.54 kilonewton is greater than the actual load of 42.28. So the design joint is safe. Hence the connection is safe in weld. Next. Next, sir. Bolted connection details. When connection is done through bolt of 12 sir, already bolted connections. When connection is done through the bolt of 12 mm diameter as per IS 800 2007 diameter. Sir, next. Already next, sir, next. Yes. Sir, we know about the conventional method joint details. So I explained that the precast joint with the help of welding, bolting and grouting. So we prepared 7 type of specimens for this research work. First one is conventional frame 1, conventional or control frame. That is control frame, single base, single story frame. Next one is prefabricated single base, single story frame, beam to beam connections. Prefabricated BF2, prefabricated single base, single story frame, beam to column connection. This is the last part is 2 types of connections we used for single base, single story. The CF 2 by 2 story with infill, that is control frame CF2, PF2, that is prefabricated 2 by 2 story with infill frames, beam to column connections. The third specimen is the important one, that is a multi-storied concept precast structure. The first one is CF3 controlled frame, 3 bay 5 story without infill frames. The last one is PF3 prefabricated 3 bay 5 story without infill frame, beam to column connection. So the first part is which connection is best for prefabricated. We researched that beam to beam connection is not possible. Beam to column connection is best one. First of all, we got the result from that 3 specimen. After we went to second research part. That part is 2 by 2 story with infill. It's a short column and shorter span. The height is very less. So it gave great result for us. CF3, that 3 by 5 story without infill, 3 by 5 story without infill, that is PF3, controlled frame and prefabricated, compared with
That the part is very peculiar one. I will explain later. Next. This is the precast single frame, shuttering and casting of raft footing. I already told about it. This is the first one is conventional method, precast single base single story frame. Next. Test procedure setup. The lateral and cyclic load is applied by means of hand-operated hydraulic jack using load cells. We are using load cells and hydraulic jacks. That frame, the testing frame contains 2000 kilonewton capacity. LVTT is used to measure the top, mid, bottom height deflection of the column are recorded at every increments of the load. The load at initial crack, ultimate crack, type of failure, etc. are also carefully observed and recorded. Loading is continued until the main tension reinforcement yields. The following regarding are observed and recorded at different stages of loading up to the initial crack and ultimate load. This is the conventional method research setup. We observed all the details accurately. Next. This is the prefabricated 2 load setup for precast frame 2. This is the beam to column joined. We using GFRP with the help of heraldite. We tightened the joint and make as a precast structure. So first of all, we using the wrapping system and find out the result. Next. In the previous part, beam to beam joint, beam to column joint. We researched that one, that the research gave a proper result for us. Beam to column joint is best one. So we try to arrange some other manner to manipulate the structure. So wherever you will go, you will get the beam column joints only. So even precast also beam column joints only. So we try to modify the joint method. Finally, it was failed. So we came to this conventional method, the same method, beam to column joint, beam to column part joined. So this is the corbel, the 2 story short column. Next. So beam to column joint, welding, bolting without infill. This is the assembled by 2 story precast frame. The foundation also precast. We prepared the specimen inside and brought the material with the help of hydraulic jacks to the loading cell area. This is a research arrangement. Shifting of 2 story precast frame to the test floor. The foundation also precast. Next. So after erection, this kind of specimen we got. Final arrangements of 2 story precast frame for testing. Next, this is without infill. This is the test setup 2 story frame. The first one is foundation block. Second one is bush jack. Third one is frame for test. Fourth one is junction box for bush. 5 oil pump unit. 6 test floor. 7 reaction frame. 8 LVTT 4 numbers. The same manner we used single base, the same setup you used for single base single story, 2 base 2 story, 3 base 5 story. This is after we constructed the brickwork inside that frame. Next, this is the final setup for 2 base 2 story experimental. So after infill the frame, we got like that specimen. We point out every joints, and we fix the pellets in the every part of the specimen. So we noted all the dimensions inside that specimen and marked red and green. Green is specimen precast element, red is pellets element. Next. So this is the final precast 3 by 5 story elements. This is it's a long column. It's looks like a long column. We gave a lot of stirrups and corbels inside that columns. So finally we got like that column specimen. This is the beam specimen. Next. Before casting, we are arranging the reinforcement like that manner. A site prefabrication work. Next. After curing and transportation and erection, after arranging all those things, we got like that specimen for 3 bay 5 story. The foundation also precast. So the same manner, already one research finished by some other research scholar, that is conventional method. We brought all the result from that conventional method frame. The same manner we used that same concrete, same reinforcement for this precast specimen also. Only extra part is corbels and joints. We arranged like that 3 by 5 story frames. Next. We move the frame to the three by 5 story with foundation. We move the frame to the test load area. Next. This is the 3 by 5 story graphical representation. I already told all those things. Foundation, one is foundation block. These are the load setup area. We used 3 hydraulic jacks. We applied a lateral load. Next. Joint adapted for prefabricated frame. For the prefabricated frame, various types of beam column joints like L joint and T joint were adapted. In this 3 by 5 story, 2 type of joint is there. One is T joint, another one is L joint. Next. This cross joint inside that frame, we got like the joints. Next. This is the column to beam joint area. Connection of beam column at typical joint. Next. connection detail. We are using welding, bolting, and grouting for the joints. This is welded connection. Next one is bolted connection. Next. Next. Observations. We applied lateral load for single base single story after we got like a crack on the joints. There is single base single story frame, control frame 1. This is a conventional method frame. Initial crack starts in beam column joint. Widening of joint cracks in joints. Cracks are propagate from bottom to top of the beam. This is the lateral. We gave lateral load to the conventional frame. So we got like that crack in the specimen. Next. Failure of frame at ultimate load. We gave ultimate load on that frame. The final crack occurred on the joint like that manner. Next. This is prefabricated frame, beam to beam column joint. Delamination of prefabricated, delamination of fabric in precast beam, cracks in beam column joints. Cracks are propagate from the beam bottom to beam top. Like that crack we got in the specimen 1, single base single story. Next. This is the shear crack in column. This is the beam column joint. The failure of beam column joint PF1 at ultimate load. Next. This is the final result for single base single story. Experimental observations of single base single story frame. Controlled frame 1. Initial crack occurred 17.14 kilonewton. Ultimate crack occurred 47.34. Deflection is 15.3 mm. PF1, that is specimen 1, that is beam to beam connection joint. That is initial crack occurred 16.46. Ultimate load 41.14. Deflection is 43.70. So we went to PF2. That initial crack occurred 17.96. Ultimate load occurred 44.07. Deflection is only 35 mm. So we went to beam to column joint. Beam to column prefabricated joints. Next. Load deflection curve for CF1. Next. Load deflection curve for PF2. This is load deflection curve. Next. This is load deflection curve for PF2. Next. Comparison of first cracking load. The first cracking load for CF1, PF1 and PF2 are shown in figure, and from this it can be understood that the PF2 is better than PF1 and CF1 because of wrapping of GFRP at beam column joint. But PF1 develops initial crack load when compared to both CF1 and PF2. That PF1 is beam to beam connection. PF2 is beam to column connection. So first single base single story gave a good result in the beam to column joint connection. So we brought the details to the next specimen, that is called 2x2 story. Next. Comparison of ultimate load. The ultimate load of all the frames were moreover same and small variation in the ultimate load in both theoretical and experimental aspects as observed from figure. The experimental ultimate load of CF1 was higher than PF1 and PF2. PF1 achieved 87% of ultimate load of CF1 and PF2. CF1 and PF2 achieved 93% of ultimate load of CF1. So the PF2 prefabricated joint 2, that means beam to column joint wrapping method is the best one. From the research, we got this result. Next. This is energy absorption capacity chart. Next. This is 2-by-2-story prefabricated frame failure pattern. These cracks occurred in everywhere. We are giving cyclic load for the 2-by-2-story. This cyclic load is like a earthquake load. So we got good result in the infill method. So in precast method also, infill method is very good. Without infill, the failure will occur easily on any structure. So like that manner, in the parking area, we will get failure easily. So if you will go for prefabricated structures, shear wall is best one for that parts. In parking area, you will use the shear walls. It's very best one. Next. Experimental results for 2-by-2-story. CF2 is controlled frame, that is conventional frame. Initial crack occurred 40 kilonewton. Ultimate load is 87 kilonewton. Deflection is 28.3 mm. Demanderly, we got a good result in infill frames. Prefabricated 2 specimen gave good result for us. The infill method, prefabricated infill method is very best one. If you will go for prefabricated, you choose a shear wall method, and in open area you use shear walls. It will give good result for your structures. That's the main point. That PF2 initial crack occurred, the same load, same manner, same material we gave properly, accurately to that specimen. Initial crack occurred 76 kilonewton only. After ultimate load occurred 228. It's a tremendous one. Our team also not believed that one. We brought our guide and researched all those things. That joined specimen all are same compared with conventional method. That prefabricated infill method is very good and very safe for earthquake structures, earthquake resistant structures. The ultimate load, same material, same reinforcement, same load, same cyclic load, we got 228 kilonewton. The same specimen gave good result. Deflection is 36.9 mm. So excellent result. Next. Initial crack and ultimate load capacity of PF2 one frame. Compared with conventional method and precast infill, there is the ultimate load chart. So we got 228 ultimate load. We gave ultimate load to the specimen 228. Next. This is the load versus deflection plot prefabricated from prefabricated frame PF2. This is the load deflection curve. The maximum ultimate load is 228. So after deflection and failure occurred on the specimens. Next. Next. Experimental observation. In summary of the above investigation into the use of glass fiber, laminates and strengthening RC beams indicates the following. It is observed that the flexural of 15.43, I think this is a single base, single story result. Go for next slide, sir. Experimental observation. Development of cracks is reduced in the beam due to glass fiber mat laminates. Widspan deflection and load capacities improvements were lowering beam where composite action between the original beam and strengthening glass fiber mat laminates were lost before complete failure of the beam. Next. Next. Three-bay five-story frame. The performance and efficiency of the connections in members of three-bay five-story precast frame with various connections subjected to lateral cyclic loading and compare the result with the control of a control frame. We compared with a controlled frame and prefabricated frame. So we already brought all the details from conventional frame, 3-bay 5-story. The frame is subjected to lateral cyclic load until failure. The efficiency and performance of beam column joints were studied at the behavior of prefabricated frame is compared with monolithic frame. We are compared the prefabricated with monolithic frame. Next. This is the experimental observation, the final result for 3-bay 5-story. The controlled frame result is 30 initial crack occurred in 32.8 kilonewton. In our prefabricated frame, initial crack occurred 76 kilonewton. It's a very excellent one because we designed the joint properly and adequate some extra care on the joints. So we got initial crack in 76 kilonewton. So the efficiency is very good. Same material, same reinforcement, same specification. We got initial crack in 76 kilonewton. The ultimate load is controlled frame ultimate load is 189.9 kilonewton. Our prefabricated ultimate load is 214 kilonewton. Deflection is 330 mm. Our prefabricated same specification, same material deflection is 430 mm. It's a good result for prefabricated structure. The initial crack load, ultimate load, and deflection at ultimate load observed for the control frame are 32.8 kilonewton. Ultimate load is 189.9 kilonewton. The deflection is 33 centimeter. For the precast frame, the initial crack load, ultimate load, and deflection at ultimate load were observed to be 76 kilonewton, 210 kilonewton. Deflection is 43 centimeter respectively. Next. Comparison of PF3 one frame, that is prefabricated 3-bay 5-story frame. The ANSYS result of PF3 precast frame were compared with the experimental result of this same frame. We compared theoretical part with precast structure, conventional part with precast structure. This is the result chart. Load deflection, there 3 bay 5 story precast bar frame. The deflection of the top story was 349.3. That's approximately it will come around 1 feet deflection. It's called 34 centimeter. From the experimental investigation, whereas it was 349.41 mm from the ANSYS analysis. In ANSYS, we got result 349 mm. The same deflection occurred in the precast structure in the test result also. The deflection at ultimate load from the ANSYS result was 0.03% greater than that from the experimental study. Sir, I'm audible?
Yes, sir. You are audible, sir.
Yes, sir.
The PowerPoint, sir?
It is not visible.
Dear friends, I am a practicing engineer. If you heard any grammatical mistake, I am very sorry, because I am doing a lot of apartment projects and promoting projects in and around Tamil Nadu. So I am roaming, I am not a professor. If any grammatical mistake, I am very sorry. So this is my result. Sir, can you show the PowerPoint?
No,
Just
sir.
a minute, sir.
Okay.
There is a network issue. So now it's visible, sir.
Yes, sir.
Yes, sir. Visible.
My main motivation is, if even illiterate people's, poor people's also doing prefabricated method to construct the houses and multi-story buildings with the help of this type of joints. So we using scrap material for the joints. So it is a very excellent thing. In India, definitely this kind of joints need for the our middle class peoples. If you need like to construct that precast structure, you can use this method and prepare the elements in your site. You definitely you will do these type of constructions. It is very economical one, time saving method, material saving method. Comparison of PF3 frame, the ANSYS result of, so already I wrote that one, sir. The ANSYS result of PF3 precast frame were compared with experimental result of the same frame. The deflection of the top story was 349 mm from the experimental investigation, whereas it was 349.41 mm from the ANSYS analysis. The deflection at ultimate load from the ANSYS result was 0.03% greater than from the experimental study. This is the final result we got from PF3. Next, sir. This is the load deflection curve for prefabricated frame, cyclic loading. Next. Initial cracking and ultimate load capacity of PF2 frame. The plot showing the comparison of ultimate load capacity CF2 and PF2 lies shown in the figure. Already I saw all those things. The PF2 showed higher initial crack load due to specially designed joints at the beam column junction, and the initial cracks were initiated at the beam column junction. The ultimate load of all frames were more or less same and small variation in the ultimate load was noted. The ultimate load capacity of PF2 was found to be 1.5 times more than CF2. See, this is a very important point. The same material used in control frame 2, the same material used for precast specimen, multi-story, a 3 by 5 story, the ultimate load capacity is 1.5 times compared with 1.5 times more than that conventional frame. But deflection PF2 for ultimate load seemed 1.3 times greater than CF2. The reading of CF2 frame was observed from the literature. Jaigro and Dr. K. Subramanian, 2011, Anna University. Next. This is the finite element modeling and validation. ANSYS is an integrated finite element analysis and design software. ANSYS is very extensive program. The element used for modeling and reinforced concrete members of the frames is solid 65. The properties of the material used for the ANSYS as listed the table. We are using ANSYS for the conventional and prefabricated frames analysis. This is the model and detail chart. Next. This is the finite element model for 2 by 2 story with infill. Finite element and analysis and modeling of PF2 frame. This frame with partial infill, frame with meshing. Next. Comparison between ANSYS and experimental result for PF2 frame. The deflection of the top story was 36.9 mm from the experimental investigation, whereas it was 35.108 mm from ANSYS analysis. The deflection at ultimate load from the ANSYS result was 5.10, lesser than the experimental study. This is the 3 by 5 story frame, finite element analysis and modeling of PF3 one frame. Next. Next, sir. This is the beam column joint PF3 with meshing. Next. Beam column joint of the PF3 one frame, 3 by 5 story frame. Next. Next. Sir, sorry. Sir, sir, this is the failure pattern in the ANSYS software. We used the same material specification to the ANSYS software. Like that failure we got from that ANSYS part, sir. In ANSYS gave 349.41 kilonewton maximum failure. Deformation, sorry, this is deformation. Total deformation is 323. Sorry, sir, please come for previous. Yes, the deflection is 349, sir. ANSYS gave deflection is 349. Deflection shape of the precast frame. Deflection ANSYS gave 349, sir. Next. This is the beam column joint 3x5 story frame, stress developed in bolt of the beam column joints of the PF3 one frame. This is the failure pattern. The deflection is 323. After failure, the ANSYS gave like that result for us. Next. This is 3x5 story. Comparison of load versus deflection values of PF3. See, control frame 1. First crack occurred at 31.2 kilonewton. The same manner we gave cyclic earthquake cyclic loading for the structure. The first crack occurred in 96 kilonewton. It's an excellent result. So, but compare with the ultimate load 214, the total structure was failure. So we won't give any load on that specimen. So 214 is the maximum ultimate load. But in conventional method, 189.9 is the maximum ultimate load. So we got a good result. Compare with conventional and precast, we got good result. That experiment is 100% success. We are very happy because we tried a lot of things, and in the initial period we got a lot of struggles. We didn't get any support from other sides, so it's a new thing. We have no code books, we have no other additional support. It's a new one for in India. 2014 to 15 I finished my doctorate. So at that manner, I spent a lot of time for that. Recently, I am doing a lot of precast works. So this is the first precast method to convert the conventional to precast. The joints is very important. So comparison of load, this is a, yes. So next slide. Comparison between ANSYS and experimental result of PF3. I already saw all those things in the ANSYS part. So we compared the ANSYS part to prefabricated structure. Both are coincidentally failure and give good result. The deflection of the top story was 349.3 mm from the experimental investigation, whereas it was 349.4 mm from the ANSYS analysis. The deflection at ultimate load from the ANSYS result was 0.03 greater than that from the experimental study. This is the final result. Compare with the actual precast specimen and ANSYS precast specimen. We compared like that manner. We got a graph sheet. We got the result. Next. Summary and conclusion. Next.
Bari sir is audible?
Sir, audible, sir.
Okay, sir. Okay, you can proceed, sir.
Conclusion. In this study, PF2 and PF3 frames were subjected to static lateral cyclic earthquake cyclic loading. So, cyclic loading also earthquake load. We are considered like that. Cyclic loading using ANSYS and results and summary are concluded as follows. The PF2 frame with partial infill at the first story and fully infilled at the second story was modeled using ANSYS software. The beam column joints were also modeled and assembled together by means of connections made of steel flats, bolts, and welds as adopted in the frames tested experimentally. The load at the failure using ANSYS analysis for the PF2 frame with infills was very close to that measured during the experimental testings. This is the infill frame. This is the infill frame result. Next.
Is this okay?
Yes, sir. The PF3, one was modeled using ANSYS software. So already I saw all those things for you. Next. This is summary of single base, single story. So in the summary, what we mentioned, if you go for any joint, column to beam joint is the best one. This is the summary result. So you don't go for any other joints. So if you go for beam to beam joint, beam to some other joints, it's definitely will give failure for your structures. So you go for only beam to column joint joints, beam to column joint designs. So next. Next, sir. This is the 2x2 story. I already told all those things. If you go for 2x2 story, infill method will give good result for your structures. If you go for precast structures, you don't go without infill. If you without infill is very complicated and critical manner. So if earthquake will occur on your area, definitely without infill, immediately failure will even precast also won't sustain in that area. So it is very critical one. We gave lot of effort to that frames. Finally, we got the result. So in the basement area, definitely you will fill with the help of shear walls in the corner area, in between area. So if not possible, you using shear wall construction in the staircase area and lift area. It's the best one. So without infill area, it's very dangerous. Even precast also, it won't sustain. We spend a lot of time for that. Definitely, the failure will occur in the open areas. The ultimate summary of 2x2 story, I already all those things. So infill is gave good result, 150% of the ultimate load. Already we saw all those things. Next. Next. Summary of 3x5 story. The ultimate load of prefabricated bare frame reached 11.26% than that of ultimate load of controlled frame. So the deflection at ultimate load was 330.4 mm, which is 55% more than that of control frame. The percentage reduction of stiffness from the first to final cycle was 83.91%. I will show the cycle details. Next and another slides will show all those things. The next 1 minute. The percentage recommendation for, sir, please come for previous slide, sir. Yes. The percentage of reduction.
Is this one?
1 minute, sir. I think my laptop, 1 minute. My final recommendation for the future research, although the work presented in the dissertation in extensive, still some more studies are to be done in this area for further understanding. The possible research investigation are given below. The connection may be tried with different techniques. So previously we are using welding, bolting and grouting method. If you have some idea to modify the connection details, it is very effective one. Definitely you will get good result. because we spent minimum amount. We brought scrap materials from the shops, so we don't spend any amount for the joints. Presently, you will spend more than 2,000 to 3,000. Advanced joints methods will you can prepare in the precast structures. Behavior of 3 bay 5-story precast frame with infill can be studied. The analytical performance of all connections with different techniques for all frames may be done and compared. The precast frame with high performance concrete and high strength concrete can be studied. The precast frame with high yield strength of steel shall be studied. Supplementary simultaneous material blended with concrete can be used for prefabricated structures. These are my recommendations. So we were planned for a prefabricated factory. So at that moment we can't do anything because the budget is very huge. So we got lot of result from that area. Still now we are trying to put a factory. Within we will start the precast factory. Next. References. Next. These are my references. If you have any idea, please go through all these books. If you want, you may send a message to me. I will recommend some books. If you will go and study these books, you will get a lot of information about the precast structure. So I published more than 24 papers in and around India and out of countries. And I got 2 central government participation in Nigam Center World Precast conference held at Bangalore and Mumbai. In Bangalore Convention Center, Nigam Convention Center, I came to the destination and gave post presentation for the scientist and went to Mumbai Shivaji Park and present my research. Research on that post presentation in front of the scientist. I think this is a great pleasure for me. These are my publications. Next. My heartfelt thanks to Dr. K. Subramaniam sir, Dr. MP Mutturaj, Dr. Committee members, my families and friends. Thank you, friends.
Shall we close this, sir?
Yes, sir.
Dear participants, if you have any doubts or any clarifications, you can feel free to ask with our today's chief guest, Gopinath sir.
Sir, good evening, sir. Myself, Ramesh, sir.
Yes, sir.
Sir, how many floors we are going to decide and construct and withstand the earthquake?
Sir,
If possible, tell me,
yes,
sir.
sir. If you
many-
go for 3 bay 5-story, my concept is if you will go for multi-story structures, first of all you will go to analyze all the parts with the help of ANSYS and other use some other software, sir. You will get
Okay,
good
sir.
result that after you will go for practically. So this is my
Okay.
suggestion, because precast is very peculiar area. We don't know anything immediately, sir. Joint is very peculiar, sir.
Sir,
So,
sir.
yes, sir. First of all, you design properly with the help of ANSYS and ETAPS. ETAPS is very important part for the precast structure, because we know the monolithic designs, conventional method. So, but precast is very difficult and different compared with conventional method. So, use this ANSYS and ETAPS, sir. So you will get
Okay,
good
sir.
after you go for multi-story structures. This is my suggestion, sir.
Okay, sir. Thank you, sir. Sir, very nice presentation, sir.
Yes, sir.
Very good
If
presentation.
any
Thank you, sir. Thank you.
mistakes, I am very sorry, because a lot of time I spend in the site only. So it is very difficult
No
to.
issue, sir. No issue, sir.
Yes, sir. But precast is very excellent future, sir. You will get it.
Dear participants, do you
Yes,
have
sir,
any
yes.
more queries? I request all the participants to switch on the camera to have a photo session with our chief guest, Dr. Gopinath sir. Participants, kindly switch on your cameras.
Thank you for this great opportunity. I think you spend a lot of time with me. If you have any doubt, make a call to me. I will send my PowerPoint presentation to you. And also, I am very interested in that area. You have any idea to start a prefabricated factory, you make a call to me. I will come and join with you.
Definitely, sir. We will try to reach out to you, sir.
Bari sir?
Sir, photo session is going on. Just a minute, sir.
Okay, sir. Okay.
Participants, do you have any queries? I think we came to the end of the today's session, sir, day 4. Thank you very much, sir. Thank you, Gopinath sir. In spite of your busy schedule, you came for us and had a brief discussion about the precast structures. Thank you very much.
Yes,
Thank
sir.
you, sir.
Thank you, madam. Thank you.
Gopinath sir, thank you very much, sir, for a very nice presentation, sir. Once again.
Thank you. If you have
Thank
any
you.
in future research, you make a call to me, sir. I have some ideas.
Yes, sir. Yes, sir. Definitely, sir.
Sure,
From
sir.
we will discuss about it.
So we will
Okay,
send a base resource person mail ID and mobile number to WhatsApp group. If anybody so to contact, you will contact that number and through mail also. Thank you, sir. Thank you very much, sir.
Yes, sir. Thank you. Thank you, sir.
Thank you, sir. Thank you very much, sir.
Dear participants, the meeting has been officially ended. We will meet by tomorrow 6 p.m. Thank you very much for your patient listening.
Thank you, sir. Thank you, participants. Thank you.